Welcome everyone. Previously, in our previous lectures, we have already built good quality background for applied bioinformatics. With the help of all relevant omics sciences, we have recovered current vaccine designs, personalized medicine, omics of cancer, and so on. But now we have another attractive subject, which is biological warfare agents. By the way, it is as old as 2000 years old. This application, biological warfare agents, applied more than 2000 years ago. My aim is not to show you how to produce biological warfare agents, but in order to act quickly, either in the fast identification protocols or making a therapeutic agents, you need to know all background about the production. In early applicants, as we don't have good quality microbiology, they are using amplified infective agents. So they were using the infected corpses, okay? And the Yersinia pestis heavily used for that applications. But later on, with the help of biological applications, purified toxins, viruses, and pathogenic microorganisms are used. As probably the most popular one is the Bacillus anthracis. You probably heard the spore-bearing letters, right? And also, there are some good quality thermostable toxins also, and their applications for the drinking water will be catastrophic. But now, I'm not gonna talk about all past applications. In order to prepare you to the future, I have to talk about the current controllable biological warfare designs, okay? So, controllable. What does it mean? Controllable. Current ones possess two important features. In controllable one, time. Mortality bias. Okay. Identification problem. Asymptomatic nature. This looks like the same, but it is different. I will talk about later why different. So, in controllable part, time is crucial. Okay. After the initiation of the infectious agent, there should be a specific time. Okay. In mortality bias, you can achieve various kinds of things like sex bias, age bias, nutrition bias. Okay. In identification problem, fast diagnostic kit resistant nature. I will explain this one later. And in asymptomatic nature, this is also different. If you think that you are sick, you probably don't go to the school, you probably don't go to the work, you will stay at home, and spreading of infectious agent won't be achieved. Okay, so symptomatic nature is important, and identification problem, I will talk this one later. Now, for time mutation rate, okay, this one is a good time measure, okay, time parameter. So the mutation rate of a virus, okay, the mutation rate of a virus is actually helping us to set up a time parameter. The mortality bias to achieve these three of them, you need humanized animals. Okay, how to achieve that? For example, if you wanted to train your virus having a different bias on mortality with respect to the different sexes, then of course use same type of animal, so same sex, okay, either female or just directly males. Okay, if you use only the one type of animal, you will train a biased manner. Okay, and then age. Not all biological warfare agents are just directly aiming humans. Okay, in some cases, targeting economy can be held by various kinds of parameters also. But for example, let's say you wanted to collapse also the economy, you will probably target also the elderly ones or the seniors. Okay, why? Because they are the history of the industry. So if you, let's say, have higher mortality rates over the age of 50, then you will probably kill all the good quality expertise bearing people. Okay, so it will cause more damage to economy. Age. Let's say you wanted to kill the elderly ones to make a bigger impact on the economy because they are the historians of the industry. Okay, so if you wanted to just make a trained virus that its mortality rate is higher in the elderly people, then you need a fast aging animal. So humanized mice. Okay, because mice are aging faster than human. Okay, so humanized mice is a good candidate for this aim. So you really don't need to modify genomes. You can train the viruses We have learned these kinds of stuff while trying to create a perfect bacteriophage that kill specific pathogens. Well, we are afraid of pathogens getting resistant to antibiotics, and in order to surpass this problem, scientists have various kinds of different applications, and one of them is having super bacteriophages that kill specific pathogens. And we have realized that bacteriophages can be trained. Okay, the genomic modifications are not so sufficient. There are various different kinds of projects in USA, and they all failed. They think that they can perform a super bug that can kill pathogen, but they realized that we do not know. We don't know various different kinds of elements at that time. A training will be much more easier and the cheapest way to achieve a better killing bacteriophages. Okay, and then nutrition, yes, because you will have various nutrition groups, okay, subgroups of the animals, humanized animals, okay, humanized animal, and each group will have different regime, nutrition, feeding regime, and from that you can have better trained viruses. Okay, and let's go to the identification problem and asymptomatic nature. The gold standard, do you know the gold standard pathogen, gold standard pathogen identification tool? It is the RT-qPCR. Okay, this is the gold standard. If your pathogen is well trained to pass this one, you will probably have a better biological war agent. So, to achieve this one, we will be using broad host range RNA viruses that can be methylated. What does this mean? This will achieve two things. First, as this is an envelope, this is an RNA genome, and these are the nucleocapsid protein. Okay, less active. Whenever they get inside the host, some regions methylated. Okay, so the new methylated 3D structure become more aggressive. Yes, and the methylation on the genome And when you know that in order to perform RT-qPCR, you isolate RNA, okay? And the RNA isolation makes the methylated RNA breaks, okay? So the methylated RNA breaks, so it is too hard for you to use gold standard pathogen identification. One part is for identification, and also this methylation is also give another interesting property. Reverse transcriptases are generally methylation sensitive. What does it mean? If the virus is heavily methylated, probably even you perform a perfect RNA isolation, the reverse transcriptases can break RNA while converting cDNA. Okay? So the reverse transcriptase while performing the cDNA, they cannot tolerate heavily methylated RNA, and they break the template so that the cDNA chopped. So kits fail. So you see, this is also important for a good biological reagent. And this kind of genomic natures for the virus, because host methylation is too differential with respect to the genomes and the age and also the nutrition, they will create also asymptomatic patients, okay, because the methylation levels is affecting whether you become an asymptomatic patient or whether you have highly infective variant. What does it mean? The 3D structure of a virus affecting the expression levels. Okay, so this is another good property. For example, if you wanted to make it 2 year, let's say, not 2 year, too much for biological war agents. Let's say 18 months. Okay, your aim is to create 18 months of effective agent, then you probably need mutation rate. If you wanted to have month, 6 months or less, Okay, in between this amount of. So with respect to the mutation rates, you can induce also the time. So in order to achieve these kinds of stuff, the crucial part is humanized animals. The cheapest ones. Okay. Do you have any question? Do you have any question? Okay, I was expecting this one. Well, you wanted to ask my opinion about COVID. Well, it looks like a trend virus, right? It looks like a trend virus, but it's a coronavirus. But the major problem for the coronavirus is the agriculture. Okay. Currently, the highest promoting force for viruses to become a trained one is the result of agriculture. Okay, it look and if you don't want to, for example, come across with these kinds of viruses, trained viruses, if you just stop agricultural multi-country how can I say this one? I really don't want to get involved with the politics, okay? Because I'm not a politician, but if you just stop consuming the okay Africa, do you know that currently most of the other countries are consuming African soils. They are hiring their soils and they are performing uh, intensive farming. Okay, intensive farming, where we will eventually have too many other trained viruses. Okay, in Africa we have too many animals. Okay, too many animals, and the agricultural lands are constantly facing with wild animals and eventually making perfect niches for viruses. Okay, so agriculture is training our pathogens. I will probably explain the mechanisms of molecular mechanisms in later, but China and some other European countries should stop using African soils, okay? Because what they are doing are just making perfect niches for increased evolution rate, okay? Evolution for RNA viruses. Do you have any question? Okay, don't worry. I will probably recover all these uh, parts because this is just an introductory part. Okay, I just give you small brief informations, and we will be covering the molecular mechanisms behind all these relevant work. Okay, so okay, let's give a break.